Right, so in this video I'm going to go through how you can kind of set up your document and your spreadsheet to gather data for your investigation. You'll be given a hard copy of a task sheet that looks something like this. You'll be given a little introduction to a real-life situation. In this case it's a baby bouncer, where you put a little baby and there's a spring and the baby sort of bounces up and down. Then you're told what your variables are supposed to be. So you're supposed to plan this investigation. The aim is to find out how the period of oscillation, capital T, is affected by the mass, M, which is suspended on the spring. Construct the spring mass system demonstrated at the right. And then you're given a theoretical equation later in the report, and you're told not to use more than 0.4 kilograms, as that would stretch the spring beyond its elastic limit. Okay, and then we're told to gather the data, analyze the data, and write the report. And we're given instructions for all of these things so that we don't forget what we need to do. And we're given an equation, a theoretical equation relating the variables. So we want to do an investigation to see if this equation is correct and to compare our final equation with this one. Right, so the first thing I would do is to create a Google Doc that's going to be my overall report. And I'll start by adding a heading here. So heading 1, I'll call it P3.1, I'll call it report, or investigation report maybe. Okay, and then I will have a heading 2, and I'll call this the plan. And then I'll just pop back to here, and I'll just have a look here. So investigation is to find out how the period of oscillation T is affected by the mass M. So independent variable, in fact, why don't we call this one heading 3. So we'll talk about the independent variable first. The independent variable, and this was given on the sheet, we're going to be changing the mass, is the mass suspended from the spring. We will use a range of 0.100 to 0.350. When you get your gear, you'll need to figure out what range to use. In this case, we were told not to use more than 400 grams, because that would stretch the spring that was set on the sheet. And the reason I ended up using only 100 grams, not 50 grams, as my lowest value, is that with 50 grams it just bounces insanely quickly. And so I'm going to talk about all of those things in my conclusion later on. And an increment size of 0.050 kilograms. Okay. And then we have the dependent variable. And I'm going to just make that a heading 3 as well. And get rid of the extra line. The dependent variable is the period of oscillation of the mass. We will measure this with a stopwatch. To improve accuracy, we will measure 10 periods and divide by 10. We will also measure each period, or measure the period for each mass 3 times and take the average to account for random errors or uncertainties. Errors, so we can say. Okay, and then we have control variables. I'm going to just make that a heading 3 as well. It is essential to control. Now we want to go back to our equation here and just see, in this equation we have T, M, and K. Pi is not a variable, it's just a number. So we're testing the relationship between T and M. If we don't control K, then our experiment will be a failure because the spring constant also affects the period. So we therefore know that it is essential to control the period of, not the period, the spring constant, K. We will do this by using the same spring throughout the experiment. Okay, and then we'll write a brief method as well. The method, this is not marked, and so don't need to sort of worry about this too much, but an experiment without a sort of numbered method doesn't really make sense. So we'll say 1, set up the experiment as shown in the diagram on the cover page, because you will be stapling the task sheet to the front of your experiment. Maybe we can just say on the task sheet. Okay, so that's this diagram here, that one there. Okay, attach 0.100 kilogram mass to the spring and release it gently so that it is oscillating. Measure the time for 10 full oscillations and record. Repeat 2 more times for 3 sets of data, and then repeat steps 2 to 4 for 0.150, 0.200, 0.250, 0.300, and 0.350 kilograms. Okay, and then we will have all of our data recorded. Okay, that's really all we need to do. Okay, now we want to put in our results and get our results table ready before we start actually doing the experiment. So raw data table, let's make it a heading 3. Okay, so to make our data table, we can call this P3.1 data table baby bouncer. Okay. The data table is basically always going to have the same structure for the raw data. We're going to have our independent variable in the first one. I'm going to just leave a line for a reason that I'll explain in a moment. The independent variable here was the mass in kilograms, and then we want mass, well, we don't need to say mass uncertainty, we'll just say uncertainty. In kilograms. And then we want our 10 times the period in seconds. And we're going to have for this trial 1, trial 2, trial 3, average, and uncertainty. And to show that that applies to all of them, I'm going to highlight all 5 and then merge. This is a merge button, it merges those cells, and then I'm going to center that one. Okay, and now I have everything I need to record my raw data, but I know that I'm going to want the actual period, so I'm going to need to divide by 10 here. So I'm going to call this period, and I will merge these two and center that period, and I should add the unit there as well. And this is period and uncertainty. I don't actually need that one above there, but I do need a unit there. This one can go away, unmerge. Okay. And then I know I know what masses I'm going to have here. 100 grams, 150 grams. Maybe it can recognize that pattern and do it for me. Yes, it did. And then I'm going to just add decimal places because I know that I measured it to the nearest gram here. And I would also by this stage know my uncertainty. In fact, I should add this in here. So I will estimate the uncertainty in the mass as 0.003 kilograms, because when I weighed the 0.350 kilogram mass, it was actually 0.347 kilograms. So by making the uncertainty in the mass 0.003, I've kind of included the value. Well, I'm going to assume that all of them are going to be within 3 grams. It's a bit of a rough thing estimating the uncertainty, but you want to be reasonably sure that you're safe, that your values are within the uncertainty that you state. Okay, so I'm going to make this 0.03 for all of them. Okay, and now I'm ready to start recording my data, essentially. So the next thing that I would do then is to actually set up the gear. I mean, in fact, I would already have set it up, because I would have trialed these things to make sure that the 100 gram mass works and the 350 gram mass works. Then I will very carefully carry out the experiment to collect the data.